So in our last project, we created a networking service, but we did it in a playground. And we created a model and we tested the model. So in this one, we're going to use the movies DB, which we've done before. If you look at some of the past videos, except this time we're going to do a search on television shows, television show titles, and we're going to create our networking service so that it stands alone. This networking service will use Combine. So yeah, I just want you to check this out, and here we go. Okay, so now I'm going to give a brief explanation of what Combine is. Combine's a reactive programming framework introduced by Apple, and it allows users to work with asynchronous events. Similar to what we've discussed in previous videos, escaping closures and async await. One of the big differences is in Combine, you have publishers, subscribers, operators, and cancellables. Publishers emit values over time, basically responses from your API call. Subscribers listens and reacts to those values. Operators do things on those, like transform, filter, manipulate those data streams. And cancellables manage the life cycle of the subscription and prevent memory leaks. This is one of the things that makes Combine superior to escaping closures, because there aren't as many issues with memory leaks and retain cycles because of cancellables. Now, yeah, a use case is, imagine you have a text field where the user enters a search term and you want to update the list and the results as they type. Okay. When with Combine, you can create a publisher from the text field, process the text, and then trigger a network request. The results of the network request can be published to the UI. Combine simplifies working with asynchronous data flows, helping you manage complex event-driven scenarios more effectively in Swift. What's the advantage of using Combine over escaping closures or async await when creating a network service? Each approach has its gives and takes, advantages and disadvantages. Combine allows you to write declarative code and describes how the data flows. Declarative code just means that the functions kind of say what it does. So instead of writing, if you're going to have a function that goes through a list of strings and removes the first three letters, instead of writing functionality that would have a for loop, right? You'd have some type of modified filter function that does that for you. Um, or something to that effect. Escaping closures and async await. These are more for kind of like basic asynchronous functionality. So you make an API call, you handle the data that comes back, and it's just not as powerful as handling complex data streams as Combine is. Yep, and of course there are built-in operators in Combine that escaping closures don't have. Handling multiple streams of data. Async await and escaping closures don't really handle multiple streams of data as well. Combine is made for that. And of course, a unified approach to asynchronous programming. Combine provides unified API for managing asynchronous programming across different aspects of the application, making it easier to learn and apply the same concepts in various scenarios. Async await provides a straightforward way to handle async operations, especially for simple one-off tasks, but doesn't unify event handling as efficiently or effectively as Combine. Escaping closures, while powerful and flexible, closures do not provide a unified approach. leading to different patterns and APIs for different types of asynchronous tasks. Back pressure management. Now let's talk about back pressure for a second. Back pressure is when you make API calls or API call, lots of data comes back, but it comes back in a way that's so fast, so much of it that um it's hard to process it, right? So back pressure kind of slows this down and assists in the processing of this data. Um, Combine offers back pressure management and allows subscribers to control the rate at which they receive data, preventing situations where they get overwhelmed by too many events in a short period of time. Async await does not inherently support back pressure. It typically up to the developer to implement such control if needed, and escaping closures also lack built-in back pressure mechanisms. So when to use Combine? When your application involves multiple asynchronous data streams or multiple sources of data coming in, they need to be processed. Reactive UI, when you want to build a UI that reacts to change over time, such as updating a list on the fly. And unified event handling, when you want a consistent approach to handling different types of asynchronous tasks throughout your applications or your application. Okay. When to consider async await and escape enclosure? Basically, when you don't have the issue of back pressure management and your data processing is pretty simple and straightforward. And when you're dealing with legacy code. And yeah, so let's get on to the example, simple example of Combine. Okay, so this is the app right here. Okay, we're making an API call to Movies DB. And if you're worrying about that, it is this. It is this. This is the Movies DB right here. But and so I'm just gonna say Knight Rider, and we pull up the names. Knight Rider. Let's do this right here. Island. What television shows have the term island in the title? Island, Curse of Oak Island, Love Island. See, all these islands. Island, 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 island. I think something wrong with this API though, because there is a show called Fantasy Island. It's not coming up. See, Fantasy Island. Um, yeah. So let's go behind the scenes and let's get down and talk about the code behind this. Okay, so let's look at our directory structure and our files. We'll have this is our networking service, TV show implementation, and TV show service key. And this is separate from everything else. If you notice, Combine is the lone place in the project where this is being used. Combine is not imported in any of the other files, period. So let's look at this. This is our URL right here. This, when we create our service object, our dependency is the bearer token for the service object. So we pass a bearer token. Do you know what a bearer token is? I'll tell you what it is. A bearer token is similar to an API key. It's another token that is sent to the API. It's not part of the query or the URL string at all. Um, it is passed here when I set value and authorization value in the URL request. It's not part of the URL string, but it is part of the request. So I'm going to break this down. Here's our URL. We create our base URL. This is the property for our bearer token. In our initializer, we have a place right here for our bearer token to be set. So the type of dependency injection is initializer dependency injection. We fetch data. When we call this function, we pass to it the query, which is the string, whatever, fantasy island, whatever. And this returns either a TV show search object or an error. Now, what is a TV show search object? Well, let's go back to our model. This is what it is right here. Right here. Of course, it's our custom data model. And I have a tutorial that shows you how to create those. So you should already know. If you don't, you need to go back and look at some of our other videos. Okay, and now this is where we have our default service key. Again, right here. In our TV show service key, environment key, this is where I implement or where we inject our bearer token right here. So it will be a long string that goes here where I have bearer token. Okay. Then of course I have these computed properties, this var that is of type TV show service protocol, which is right here. And these computed properties, they get and set, right? So you get a value, right? And you set our value. The value is set to be equal to the new value. Wherever I'm resetting this, it sets it to where it's able to be set to the new value. But I'm not doing a tutorial on computer properties. So we have our app colors utility, and this is basically constants for the colors and the layout for our UI. And then we have our content view. Okay. And our content view, this is the layout for the UI that I showed you guys. Okay. Okay. So our content view. And let's see. Right here. Well, actually, I do use environment variables. My bad. Right here, our TV show service of type TV show service protocol, which I've already shown you guys. Well, maybe I didn't. Let's go back here. This is our TV show service protocol. That's all. And as you see, our app styles are set in the padding, the colors, all throughout here. TV show search. TV show service. So let's see where this is being used. Command F, V. All right, let's see. Okay, right there. Cancelable. Our TV show search is here. And of course, it's being set. And so what I need you guys to do is I have uploaded this entire project to GitHub. I'm going to give you the link. And you can download this and go through the code yourself But the real focus of this is really the TV show service implementation and the TV show service key using initializer dependency injection for this service. Take this down, play with it. That's the best way to learn. Me going step by step, typing out the code while I tell you what I'm doing is wasting your time and mine, especially your time. You need this code in front of you so you can step through it and look at it. This is the type of code that you're probably going to see in places of employment. So now's the time. No one else on YouTube is giving you this but me. So, yes, and we're on to the next.